Now let's try to understand whether the equations which we write for line in R2 or R3, that means 2-dimension or 3-dimension, we are writing them in different forms. Are they unique or not? This is the question. So we'll test the uniqueness of our equation to represent line in Cartesian plane or in space. So the question is, true or false? Explain your answer with example. Vector equation of a line in R2 is unique. Is it true or false? And give your reasons. Scalar equation of a line in R2 is unique. Cartesian equation in R3 is unique. Symmetric equation in R3 is unique. So I'd like you to pause the video, answer the question, and then look into my suggestion. The first one is, vector equation of a line in R2 is unique. Now, how do we write this equation? Now, generally, vector equation of a line, let's say R is the line, is equal to a coordinate point on the line. Let us say any coordinate point 1, 2. So this is a point on the line, plus t times the direction vector. And let's say the direction vector is 3, 4. So that is how we write the vector equation of a line. Now here, 1, 2 is any point on the line. Now how many points do you have on the line? Infinite, right? So there could be infinite ways of writing this particular equation, right? You can consider any point on this line and write down your equation. So it cannot be unique, right? So it has so many different ways in which it can be written. Here is a point on a line. So whenever we are referring equation with a point plus something else, it cannot be unique. So this is false. Next one is scalar equation of a line in R2. Scalar equation is of the form of ax plus by plus c equals to 0. Now here, a and b, what are they? They actually represent the normal vector. So a and b represent the normal vector. So if I write this equation of line, then normal vector is ab. Now this equation is written in terms of normal vector, and that is unique, right? And we don't have really combination of such points with this normal vector. So scalar equation of a line in R2 is always unique, and that is true. The third one is, Cartesian equation in R3 is unique or not? Well, the answer is very simple. In R3, we do not have any Cartesian equation. Well, scalar equation and Cartesian equation are alternate names. In R2, scalar equation is also called Cartesian equation. But if I write ax plus by plus cz plus d equals to 0, it becomes the equation of a plane. Do you know the reason why? In R3, that means space, if you have a line, then there could be so many normals, right? Kind of think like this. Think about a line coming out of this page, like an arrow. Then every line on this page is normal to that line, right? You understand? Our line is coming out of the page, so every line on this plane is normal to that line. So that equation will actually become equation of a plane, not of a line. So ax plus by plus cz plus d equals to 0 is actually equation of plane, which we are going to study soon, but not of a line. And the reason, I hope you understand. Now think about it. If you have a line getting into this paper, let's say this is arrow indicating going inside. In that case, the whole plane, any line on this plane is going to be normal to that line. And that represents a plane, not any one of those lines. Do you see that? So this statement is false. The last one is, symmetric equation in R3 is unique. So symmetric equations are of the form of x minus x0 over, let's say, direction vector in x direction equals to y minus y0 over d2, which is equals to z minus z0 over d3, right? And all these are actually equal to some parameter. Now, as you can see here, it is represented in terms of a point on the line, right? Now, as you can see here in vectors equation, there are infinite points on a line, and therefore symmetric equation in R3 is not unique, so it is false. So the only equation which actually is unique is a scalar equation or Cartesian equation in R2. All rest of the equations are not unique, so you can always have more than one answer. Okay, I hope you understand the concept, and most important, you also realize that what we could have had a Cartesian equation in R3 that really represents a plane and not a line. Okay, and that's the reason why. Thanks a lot, and I hope you are learning as we move forward, and let's learn more about lines in R2 and R3. Thank you and all the best.